Hello everyone. I wanted to work this problem from deep in the 9.5 problem set. It is the full Monty, so to speak, in that to navigate this problem, you're going to have to really know your stuff. And we'll get after that in a second. But I wanted to sort of thread this video together with a timeline. Here is the cover of the textbook that I had when I took intermediate algebra 30 years ago. And back then, scientific calculators were just coming into the fore. They had, of course, been invented, but they were still extremely costly. To have one that would do logarithms was several $100s. And so the textbook back then, as they had for hundreds of years, included log tables. And here is a scan of the log table from my textbook. And as you can see here, we would have problems like the one we're going to solve here shortly, but essentially we would find an approximation for log to the base 10 of 2 by going to the table. It wouldn't be given to us. So we'd go in here and we look up 2, and this is the column that we would choose. And as you can see, we have the same value to 4 significant places. This table is 4 place significant, and there are tables that you could find that are 12 place significant depending upon the necessities of your calculations. Now the whole thing here is that logarithms were invented and they brought heaps of praise down on their inventor because they simplified extremely difficult calculations. And in this problem you're going to see that, and it threads through it, and we'll check it out from that angle. What they're asking us here is that knowing only these two values, these two logarithms, approximate the following right here to 3 decimal places. Now imagine this problem, you had to do this problem 150 years ago. And actually imagine it in the other context, the other way of translating logarithms. This is the exponent. You raise 12 to get 36. In other words, this problem is really this problem. We want to solve for that question mark. What is a number that you raise 12 to get 36? Now this is a problem that may have cropped up 100 years ago in a math problem, an engineering problem, a astronomical problem. At any rate, it had to be solved, and all you have is paper and pencil, no calculators. How would you go about getting an answer for that? Well, logarithms simplified these sorts of thorny calculations dramatically. And of course you could get a really quick estimate. Here's 12 to the first power, you get 12, and 12 to the second power, you get 144. So whatever you raise 12 to get 36, it has to be between 1 and 2. But that's a pretty wide range of values. And so we will actually come to 3-place accuracy by using log tables here. And here's how we do it. The first move is to rewrite 36 as a power of 2. Now, there are many paths you can take from here, but why I'm rewriting this as 6 squared, 36 as 6 squared, is because it allows me to use the third law of exponents. And here is a scan from my old textbook of those 3 laws. And these are the same 3 laws that are in your textbook, and the same 3 laws that will be in your children's intermediate algebra textbook. They won't change. And we are going to, in this problem, evoke laws number 1 and number 3. Right now we're going to use law number 3. And what happens here is that you can change, when you're taking the logarithm of some number being raised to a power, you could rewrite that power, that exponent, as a product out in front. So in a sense, what we're doing here is we're changing exponentiation to multiplication, which is easier to do. And that's one of the beauties of logarithms. They exchange operations to simpler operations. We're also going to use the first law of logarithms. Notice we're taking the log of 2 numbers that are being multiplied together. And we can change that multiplication to an addition. And obviously addition is simpler than multiplication. We won't use the second law of logarithms, but please note that it changes division into subtraction. Now, would you rather do a long, thorny, long division problem or a simpler subtraction problem? So that's the power of logarithms. And I'll use that third law right now to change that exponentiation into a product out front. Now, I'm going to rewrite the 6 in terms of its prime factors, 2 and 3. And the reason why I'm doing that is because everything has to be written in terms of log to the base 10 of 2 and log to the base 10 of 3. These are the only two values I have to work with. They didn't give us the log table, and we don't have a calculator. Well, we don't have a calculator for logarithms. That's presupposed by the problem. At any rate, what happens here is this is to the base 10. There's no base shown, so it's implied. Our problem is to the base 12. We're going to have to change this to the base 10. That means I need to use the change of base formula, which looks like this. Now, I'm not going to talk you through this because at this point in time in the course, you're supposed to know how to use that formula. I'm simply going to rewrite it using that formula. And when I do, we get something that looks like this. Everything now is to base 10. And now I'm simply going to rewrite the 12 in terms of its prime number atoms, which are all 2's and 3's. And you can see that this problem has been carefully contrived to generate just factors of 2 and 3 because we only know those logs. Now, of course, we still have that factor of 2 out in front, and we'll have to carry that all the way through. At this point in time, we're going to evoke the third law of logarithms, and we're going to change all those multiplications into addition. And that will look like this. And now, pretty much, this is a straight substitution problem. All we need to do is wherever log 2 appears, replace it with this 3-place value, and wherever log 3 appears, replace it with this value. And when I do that, I get this. And essentially, we just have to crunch that out on with pencil and paper or with a calculator, and we'll get this. So lo and behold, that is the number that you raise 12 to get 36. And look how with the logarithm tables in the olden days, you could have looked these two values up like I did. Look what this problem reduced to right here. That's phenomenal. We found the power you raise 12 to get 36 by just doing additions, multiplications, and a simple division. That was the power of logarithms. Of course, things have changed. Your textbook doesn't have log tables because scientific calculators are prevalent and cheap, and it's just a push button away. And I would argue that this problem right here is in itself on the way out. That 10 years from now, this problem won't be in the intermediate algebra textbooks because of this tool. This is Wolfram Alpha, and I don't need the change of base anymore. All we need to do is simply write it like this. Find me log to the base 12 of 36, and it tells us the answer without any fuss. And so eventually education will catch up to this new tool, but for now we will play the game and learn from it. Hope this helps. Talk to you soon.